ನಮ್ಮ ಕ್ಲಾಸ್ ಇದೆ 1:10 ಕಾಲ್ ಮಾಡ್ತೀನಿ ಮ್ಯಾಮ್. Just now started. Yeah. Yes, ma'am. So good afternoon, dear students. It's good to go. We'll be starting with module 4 today. So it is regarding HDFS, one of the very important technology in big data analytics. This is what we discuss in today's class. Hope I'm audible, right?
Yes, sir.
Yeah, thank you, Arpita, for the confirmation. We'll start today's session on HDFS. So this is module 4. And as you know, from next week onwards, we are having online test. Okay. So kindly be prepared with module 1. Meanwhile, I'll be doing revision of module 1 tomorrow and day after tomorrow. I'll be doing some revision. Okay, so it's very important. The exams will happen simultaneously along with the theory classes. So morning you will be having exam, and afternoon after the exam, the internal exam, you will have the classes as usual running. Right, the agenda for today is an overview of HDFS, design of HDFS weaknesses, and HDFS concepts. So when you take HDFS concepts, we'll discuss about one of the concept called blocks, HDFS blocks. We'll discuss that in detail. So in module 4, the syllabus goes like this. So we have the design of HDFS, HDFS concepts, blocks, name node, data node, HDFS federation, HDFS high availability, the command line interface, basic file commands, operations, HDFS file systems interfaces, Java programming interface, how we can write Java program interface with HDFS, reading data URL from HDFS, reading data using file system API, writing data, dictionaries, querying the file system, deleting the data, data flow anatomy in HDFS file read-write systems. Of course, finally, we discuss a coherency model, parallel copying using disk copy, keeping HDFS cluster balanced. So how this HDFS keeps the clusters balanced. And finally, we discuss about archives, HDFS Hadoop archives. This is what we have in module 4. Module 4 completely talks about HDFS in detail. So HDFS detailed discussion, we will have it in module 4. So first of all, let us start with HDFS. So HDFS, we know very well, it is a distributed file system, Hadoop distributed file system. Why distributed file system? Because of only one reason. So we need to handle big data. Big data handling cannot be done with one computer. It has to be done through set of series of networked computers. So distributed file system is required. So that is a file system that manages the storage across networks of various machines. We call it as distributed file systems. And of course, since they are network based, all the complications of network programming kick in, and thus making distributed files more complex than regular disk file systems. One of the biggest challenge is making the file system tolerant towards node failure. Suppose you are maintaining the files in various computers, nodes. If the node fails, what happens? Particular portion of data, we cannot use it. You cannot use it, a particular set of data. So obviously what happens, there is a suffering of data loss. So that happens with respect to HDFS. Hadoop comes with a distributed files system called HDFS, which is a distributed file system, developed for handling various Hadoop environment. So all in the previous class we discussed about, we had a seminar on Hadoop ecosystem. The Hadoop ecosystem is totally completely based on HDFS. HDFS is the base for all those technologies. First, data has to store efficiently. Later, you can analyze, you can do other tasks. So it is just like that. And of course, coming on to the characteristics of HDFS. HDFS is a file system designed for storing very large files with streaming data access patterns. What is streaming data? Data that is coming at a regular interval. The data will come without any, stop. They'll be flowing in. So, example, the video data or the tweets that are coming or the messages that have been transmitted running on the, these HDFS will run on the clusters of commodity hardware. Commodity hardware, the common hardware that is available. So you don't use any special hardware. So the common hardware. And HDFS are designed for to handle very large files. Very large in this context means files that are hundreds of megabytes or gigabytes or terabytes in size. There are Hadoop clusters running today that store even petabytes of data. So these are all a huge volume of data that we have. Coming on the next characteristic, it is streaming data access. Hadoop is built around the idea that the most efficient data processing pattern is write once and read many times. So very, very, very important, because in our further programs, whenever we execute our programs in MapReduce, what happens? We face this. So once you execute the program, the output file has to be, removed, because it is a write once and read many times. So this is the concept. So you write the file only once, but you read it many times. The data set is typically generated or copied from the source. Then various analysis are performed on the data set over time. So this is one of the very important concepts that we should have. Each analysis will involve a large portion, if not all, of the data set. So the time to read the whole data set is more important than the latency in reading the first record. So if the data set is stored in various computers as a species, so the simultaneous reading of data set will be important. When it comes to the entire data set readability, not the first record reading. So that is one very important concept. So data streams are being handled very efficiently. Further, so this entire HDFS is built on commodity hardware. So that is, Hadoop does not require an expensive or highly reliable hardware to run on it. So it's designed to run on clusters of commodity hardware. So commodity available hardware, where multiple vendors, different vendor hardwares, normal hardware. But the problem is with the commodity hardware, they are available at lower cost and common hardware. They are having lot of chances of node failures across the cluster is very high. So the failure rate is very high with respect to commodity hardware. At least for large clusters, this happens, and HDFS is designed to carry on working without noticeable interruptions to user in the facet of the failure. So sometimes the HDFS should handle all these things in case of failure. In case of failure, so that is one very important thing. HDFS does not work so well. These are the areas where HDFS are not, good fit today, because HDFS is designed for a high latency. So low latency data access, the application that requires very less reading, time, very less data, in tens of milliseconds range, will not work well with HDFS. Remember, HDFS is optimized for delivering high throughput of data, and this may be at expensive of latency. And if you have a lot of small files, since name node holds files, metadata in the memory, in the limited number of files in the file system is governed by the amount of memory on the name node. So it becomes very difficult for HDFS to handle small files. So if you have a lot of small files, it is very difficult. So that is one point that we should, consider it. And as a rule of thumb, each file, a dictionary, or a block takes about 150 bytes. So in normal file, so block will take, normal file blocks will be 150. For example, if you have 1 million files, each hold one block, it would be at least 300 MB of memory. While storing millions of files, it is feasible, that is billions, it is beyond the capability of the current hardware. Of course, so it is, if you have small files, that is exactly very difficult for HDFS to maintain all those files. And not only that, files in HDFS may be written only once, and read many times. So if you have multiple writes, arbitrary file modification, arbitrary number of modification, any number of time the file modification, this cannot be certainly used. So files in HDFS may be written to a single write, but writes for multiple time, it is not supported. So there is no support for multiple writes or modification. So that is another disadvantage of HDFS. So the reason is, so HDFS is mainly designed for analyzing, storing the big data, and big data will not be generated, will not be altered every time. Big data will be generated, but it will not be altered. So it is designed for that system where it will store on the device various nodes, and once these nodes stores this data, that can be read any number of time for analysis. So the concept of HDFS, the rule of HDFS is write once and read many times, but multiple writes is not supported. So that is one very important thing that we should understand with respect to this. When we look into HDFS concepts, we have the concept of blocks. HDFS follows different block size. There is a reason for it. We'll discuss that. And HDFS also has name node and data nodes. So these name nodes and data nodes are quite important in managing entire operation of Hadoop ecosystem. HDFS Federation. HDFS Federation is a various collection of tools that are working together, and HDFS has a component called high availability. So even there is a problem of commodity hardware, network failure, node failure, data failure. So with all those things, data is still available. High availability. Never it will have the concept of failure. So even though there are a lot of problems with respect to data nodes and data storage, still Hadoop manages in such a way that there is always data available, high availability. So coming on to the first concept of HDFS, so we'll see the blocks. So what is a block? In fact, disk has a block size. So normally our data will store in blocks on the disk, okay, which is minimum amount of data that can be, that can be written and read straight away, read or write. So straight away, a computer can read so much of data at once, so much of data at once it can write. So that is what you call it as block. The block size. So normally, for what is the file system? So file system, if you look at file system, is a single for a single disk built on this by dealing with data in terms of blocks. So many such blocks, if you collect, it becomes a file system, which is an integral multiple of many disk blocks of sizes. So that will create a file system, and the basic component of a file system is a block, file block. And of course, file blocks typically are a few kilobytes in normal systems, Windows, normal in Unix, Linux. It is 512 bytes. 512 bytes in normal systems, normal, but the same is not for HDFS. HDFS follows a different blocking system. Okay, this is generally transparent to file system users who is simply reading or writing the file whenever they want to do any operation, irrespective of the length of the file. That is being followed. So that is one very important thing. There are tools to perform file system maintenance, such as df. Df is a command. It will tell what is the number of disk free is available. FS check, file system check, to check what are the blocks available, how many blocks have been occupied, what is the percentage of free blocks, what is the percentage of blocks that are being filled. So this is DF and FSCK are Hadoop commands. See, Hadoop commands are different. Hadoop follows a different command line system. So if you look at further HDFS, you will write a lot of commands. You have to learn a lot of commands. In order to understand all these things, how exactly the data blocks are created, how exactly the file systems are being operated. So that operates on file block level commands. These two commands operates on file system blocks, especially on Hadoop systems, HDFS commands. Of course, see, 512 bytes it is with respect to normal Hadoop system. Normal system. For a Hadoop system, it is 64 MB. 64 MB. No bytes, it is megabytes. Okay, observe very carefully. HDFS 2 has the concept of block, but it is much longer unit, 64 MB by default. So, which is the size of the HDFS block. One block will store 64 MB of like file system for a single disk. The file in HDFS are broken into block-sized chunks. So every block in HDFS is of 64 MB, which are stored independently in different computers. And remember one very important thing: Hadoop follows replication. You know what is replication? It will not store a block of data only one computer. It stores in 3 different computers. So same block, the entire file, big file, whatever you give, big data, whatever you give, the entire data is split into 64 MB, 64 MB, 64 MB, 64 MB, 5 blocks. And these 5 blocks are stored across various other computers, and each block is maintained 3 times repeated because of fault tolerance. Suppose some block get damaged, it will look into the other blocks, so other 2 blocks. Okay, so that is what you call it as a replication. Replication is a component where the blocks are stored redundantly at various other places. And of course, unlike a file system, for a single file in HDFS that is smaller than a single block does not occupy a full block's worth of underlying storage. See, if a file does not occupy less than 64 MB, then that block is not worth. So it will waste the entire block. So why block system is maintained in Hadoop HDFS, distributed file system, so large? So the HDFS blocks are large to the disk blocks. When you compare normal disk for a block, it is only 512. But HDFS, if you look at it, is 64 MB. There is a huge difference. Why is that? That was the question. So the reason is to minimize the cost of seek time. Seeking is nothing but reading of the blocks. If you have small blocks, small size blocks, every time you will read, a lot of time is spent in reading. So what happens? It creates a problem. Instead, you read the entire block at once. So by making the block large enough, the time to transfer the data from disk to the main memory is can be made significantly larger than the time to seek the start of the first block. So this is one very important reason why the HDFS block size is 64 MB, so large. And many times it has been asked in the examination also. Thus, the time to transfer large file made of multiple blocks operates at different disk transfer rates. So definitely that will be beneficial because you are handling big size data. So when you are handling big size data, this is going to happen. So a quick calculation, if you look at shows that if the seek time is around 10 milliseconds and transfer rate is 100 MB per second, then to make seek time 1% of the transfer time, we need to make the block size around 100 MB. By default, actually, we have 64 MB, although many HDFS installation make certainly 128 MB, so double the actual size. You can configure, you can change the minimum block size. You can make it as 64 MB. Maximum you can make it as any number that is left to your system admin configuration. So if somebody makes 128 MB blocks, so what happens? The figure will continue to revise upward transfer speed growth in the new generation of disk drives. So disk drives, we are getting faster disk drives right now. So what happens when we are getting high-end disk drives? Certainly, if you have small blocks, so your file system become slow. So if once the file system is slow, the entire system will become slow. So the first and foremost basic component is that your file system should be fast. So if you want to make your file system should be fast, your block size should be large enough to read at once. So normally it will be maintained at 64 MB. You can configure to make it till 128 MB block size. So that is another good thing about HDFS that you should consider. Once the speed of storage, reading and writing of data is fast, you can do any operation based on that. The basic operation is reading and writing. If that is fast, that is taken care very efficiently, further any operation we can do it at very good speed. In the next class, we will discuss about name node and data node. So that's all for today's class. One small announcement that I would like to make. So we have already seen that yesterday our principal has announced we will have internals online, and in one of the today is a newspaper also it has come that VTU is insisted to conduct online tests for internal assessment. So in order to work with internal assessment and in order to make digital announcements, so yesterday I've requested some of your friends to join to this Google Classroom. So Google Classroom to join. So far only 16 students have joined. So the joining is very simple. I have sent a small video regarding this in the morning, and my big data analytics class code is this one. So how you have to use this? Very simple. Go to your browser. You can do it in your mobile also. So go to your browser. Okay. So I have chosen. So here, once you click on the Google Apps, so you will see a lot of apps here. Once you choose Google Apps, go to Google Classroom. Once you are in the Google Classroom, immediately, so what happens? It will display. Click here on the plus to join to the classroom. So just click on the plus and join class and enter that code. So the code which I have typed is something like IT5MB7I. IT, yes, where is it? Yeah, it is here. IT5 MB7I. If I just say join, that's all. I'm joining into the class. So this is how you have to join. If everybody joins to the class, certainly we can do a lot of other things. So I can announce, I can, in order to conduct online examination, in order to conduct online test, in order to track your assignments, this will be very helpful platform. So I expect everybody to join to this class as early as possible. And maybe Saturday I may give one trial test run on this Google class platform. So once you join, you will easily understand this. You'll understand this. So that's all for today's class. That's all for today's class. The entire class recording will be available on this website, as well as the study materials available. Hope, I think everybody, you should be ready with module 1. And in module 1, we will be, asking a lot of multiple choice questions. So you are supposed to answer. Meanwhile, this Saturday we'll run a small trial of your online quiz. So for this, I want everybody to join to the Google Class platform. So that's all for today, and maybe from tomorrow onwards, 10 minutes, every 10 minutes, and the class itself, I'll do a quick revision of module 1, so that it becomes very easy. So morning you will have test, and after the test you will be having the regular classes. That's all for the day. Thank you. Have a wonderful day.
Thank you.
Thank you.